So for this section, we're going to go over solving systems of equations by graphing. So what I mean by system of equation is when you have two or more equations within one system or as a group. So we have two equations here with two unknown variables. So if you were to solve for x and y, you would need at least two equations for sure. If you only have one equation with two unknown variables, then you can't solve for it. It's going to be hard to find the values for x and y if you're just using one equation. So, in review, when you're solving for unknown variables, in this case you're solving for the value of x and the value of y, we need at least two equations. So here we have a system or a group of equations, two equations, two unknown variables, x and y, and we're going to solve for it by graphing. Alright, we're going to work on the first equation, 2x minus 3y equals 3. So when we are just graphing, all we need to do is convert it into slope-intercept form, because right now it's in standard form. So I'm going to write the equation right here. So 2x minus 3y equals 3. So again, we're in standard form. When we need to graph, we have to convert into slope-intercept form. So I need to get rid of the x, the 2x from the left. So I subtract it because it's the opposite of positive 2x. So on the left, I'm going to have minus 3y equal. Now 3 minus 2x, you can't combine them, so it's just going to be simply be negative 2x plus 3. And then I want to get the y by itself, so I'm going to divide everything by negative 3. When I do that, I'm going to have y equal negative 2 divided by negative 3 just simply becomes a positive 2 over 3x. Positive 3 divided by negative 3 would just simply become negative 1. So here is our slope-intercept form. So y equals 2 over 3x minus 1. And let's graph that. So our y-intercept is at 0, negative 1, which is right here. So we have a positive slope. This one, it will go up 2 and then right 3 since it's a positive slope. So I'm going to go up 2, 1, 2, and then right 3, 1, 2, 3. So here's our second point, and then I'm going to graph connecting these 2 points. Alright, so we have our first graph. Let's do the second one. So it's x plus 3y equal 6. Now doing the same process, we just want to get 3y by itself, so I need to get rid of the x. The opposite is minus x, and I do it on the right side. Alright, so the x cancel out, and on the left side will be simply 3y equal 6, and negative x cannot be combined, so I'm just going to simply write negative x plus 6. And if I want to get y by itself, I'm going to divide everything by 3. So, dividing everything by 3, I'm going to simply have y equal negative x over 3 is the same thing as negative 1 over 3x. And then positive 6 divided by 3 would be simply positive 2. So here's our second line. Y equals negative 1 over 3x plus 2. Alright, graphing our second slope-intercept. our y-intercept will be at 0, 2. So it's going to be right here. And then since it's a negative slope, that means I'm going to go down 1 and then right 3. So negative slope, down 1, right 3. So down 1, right 3. 1, 2, 3. So here's our second point. And then I'm going to graph connecting these 2 points together. Now, when we graph and we just look for where the 2 lines intersect. So the 2 lines that intersect here, which is 3, 1. So I'm going to write right here, 3, 1. So when you see an intersection, that's our solution. So when you're solving for the value of x and y, we would just write it as a coordinate. So our solution, you just say solution is 3, 1. So you can write like that as a coordinate point, 3, 1. Or you could just say x equals 3, y equals 1, but it's easier if you just write it as a coordinate point. Just like this. So again, when you're graphing 2 lines, you look for where they intersect. In this case, at 3, 1. So that's going to be our solution. When you plug these in, for x and y, it should equal to 3. And over here, when you plug it for x and for y, it should equal to 6. Alright, so we have in our second example, 5x minus 2y equals negative 10. And our second equation, x plus 2y equals negative 2. So, the first thing we're going to do is just convert these 2 standard forms into slope-intercept form. So, I'm going to work with 5x minus 2y equals negative 10. So, 5x minus 2y equals negative 10. I want to get negative 2y by itself, so the opposite of 5x is negative 5x or minus 5x. Since I'm subtracting 5x on the left, I subtract 5x on the right. So the 5x cancel out, and all I have is just negative 2y on the left side equal negative 10 and negative 5x cannot be combined because this is a number, this is a variable, so it's simply going to be written as negative 5x minus 10. So when we have that and I want to get y by itself, I'm going to divide everything by negative 2. So negative 2 here, negative 2 here, and negative 2 here. So when I divide that, we're just going to have just y equal negative 5 divided by negative 2, where we simply become a positive 5 over 2x, and then negative 10 divided by negative 2 will simply become a positive 5. So here's our first slope-intercept. So I'm going to graph our first line. So our y-intercept is at 5. So here's our first point. Alright, now since this is a positive slope, if I were to go up 5, I'll be out of the range. So if it is up 5 and right 2, so what I'm going to do is going to be the opposite. So I'm going to rewrite the slope here. So 5, 2. So I'm just going to do the opposite. So instead of up 5, I'm going to do down 5. And then instead of right 2, I'm going to do left 2. Since I cannot go beyond the graph, I don't have any more room. Because here, the original slope, I had to go up 5. If I were to go up 5, I'm out of the range. So I'm just going to go in the opposite direction to get our second point. So I'm going to go down 5. 1, 2, 3, 4, 5, and then left 2, 1, 2, right here. Alright, got our second point, so I'm just gonna connect them. Alright, here's our first line. Alright, now we're gonna work on the second one. X plus 2y equals negative 2. Alright, I want to get 2y by itself, so I want to get rid of the x. So opposite of positive x will be minus x. I do it on the left, so I gotta do it on the right. X cancel out, so the only thing I have left is 2y on the left side equal negative 2 and minus x. They're not the same, so I can't combine them, so I'm just going to write it as negative x minus 2. And since I want to get y by itself, I'm going to divide everything by 2. So 2y divided by 2 would be simply become y. Negative x divided by 2 would simply become negative 1 over 2x. And then negative 2 divided by 2 would simply become negative 1. Remember, if you just only see a negative x, it also means negative 1x. That's how I got negative 1 over 2. So here's our second slope-intercept. And we're going to graph our second line. So our y-intercept is at 0, negative 1, so right here. And then according to our slope, since it's negative, we're going to go down 1 and right 2. So negative 1 over 2 means down 1, right 2. So I'm going to go down 1, right 2. So here's our second point. And then I'm going to graph by connecting those 2 points. And then I see that our 2 lines intersects right here. So at this intersection, the coordinate point is negative 2 for x and then 0 for y. So again, my x value is at negative 2 and my y value is at 0. So the solution set for this system, 5x minus 2y equals negative 10 and x plus 2y equals negative 2. So our solution is the coordinate of negative 2 comma 0. So that's all you have to write for this system, and then to simply box it like so. And that's all you have to do. Alright, in our third example, we have a system of 3x minus 4y equals negative 12 and 3x minus 4y equals 8. Alright, let's convert the first one into slope-intercept form. If I want to get rid of the positive 3x, I gotta do the opposite. So negative 3x on the left, and then negative 3x on the right. So on the left side will be simply be negative 4y equal negative 12 minus 3x. Can't combine them, variable and a number. So it will simply become negative 3x minus 12. And then if I want to get y by itself, I'm going to divide everything by negative 4. So when I do that, it will become y equal negative 3x divided by negative 4 will simply become a positive 3 over 4x, and then negative 12 divided by negative 4 will become a positive 3. So here's our first slope-intercept form. Y equals 3 over 4x plus 3. So our y-intercept will be at 0, 3, which is right here. Now, looking at our slope, it's positive, so I'm going to go up 3 and right 4. So 1, 2, 3. Yeah, I can work with this slope. So it's going to be up 3, 1, 2, 3, and then right 4, 1, 2, 3, 4. Alright, so I'm going to connect those 2 points. Alright, so here's our first line. So let's work with the second one. 3x minus 4y equals 8. Alright, so I want to get rid of the 3x so I can get the negative 4y by itself. So the opposite will be minus 3x minus 3x. So the 3x cancels out, and then on the left side will be negative 4y, and then equal sign. 8 and negative 3x cannot be combined because it's a number and a variable. So it will be simply be negative 3x plus 8 on the right side. And now, when I want to get the y by itself, I'm going to divide everything by negative 4. Divide by negative 4. Divide by negative 4. So doing so, I will have negative 4y divided by negative 4 would be just y. Negative 3x divided by negative 4 simply become a positive 3 over 4 x, and then positive 8 divided by negative 4 will become negative 2. So here's our second slope-intercept form, and we're going to graph our second line. So our y-intercept will be at 0, negative 2, which is right here. Positive slope, so that means I'm going to go up 3 and right 4. So up 3, right 4. 1, 2, 3, 1, 2, 3, 4. So here's our second point. I'm going to graph that. Alright, looking at the graph, I notice that these two lines don't intersect, and as I look closer, it seems that they have the same equal distance between the two lines, so that means they're parallel. So let's take a look at the slope-intercept form. I notice that they have different y-intercepts, plus 3 and minus 2, but if you look closely, the slope in front of x, 3 over 4 on this one right here, and 3 over 4 on this one, and they both have the same sign, positive 3 over 4, positive 3 over 4, so they have the same slope. So if they have the same slope, that means that these two graphs are parallel. So if they have the same slope, different y-intercepts, and as you graph them, you can see that these two lines are parallel. If they are parallel, they won't intersect, they won't touch each other. That means that there won't be a solution. So in the event you have a system where the slopes are exactly the same sign of course, but different y-intercepts, and when you graph them, you have two parallel lines, you will have no solution. The reason is because two parallel lines, because of the word parallel, meaning that they go in the same direction but never touch each other. So when they don't intersect, meaning touch each other once, there won't be a solution. So in this system, these two equations are parallel to each other because they have the same slope, therefore they have no solution. Alright, in our fourth example, we have this system 12x plus 6y equals 6, and the second one, 4x plus 2y equals 2. Alright, so let's convert it into slope-intercept form. So 12x here, 12x plus 6y equals 6. Alright, so if I want to get 6y by itself, I need the opposite of 12x, which is minus 12x on the left, and then minus 12x on the right. So on the left side, the x cancel out, and all I have is just 6y equal 6 minus 12x can't be combined because variable and number, so simply become negative 12x plus 6. And if I want to get y by itself, I'm going to divide everything by 6. So, doing so, we're going to have just y equal negative 12x divided by positive 6 would become a negative 2x. Positive 6 divided by 6 will be positive 1. So here's our first slope-intercept. And then I'm going to graph that. So y equals negative 2x plus 1. Now, we have a whole number, so we're going to convert it into a fraction. So I'm going to put it over 1. And since it's a negative slope, that means it's going to go down 2 and right 1. So negative 2x is the same thing as negative 2 over 1. So down 2, right 1. So our our y-intercept plus 1, that means 0, 1, which is right here. So I'm going to go down 2, 1, 2, and then right 1. So there's our second point. So I'm going to connect those 2 points together. So there's our first graph line. Alright, now the second one, 4x plus 2y equals 2. Alright, if I want to get the 2y by itself, I need to cancel out the 4x, so the opposite of 4x is minus 4x. Subtract 4x on the left, I gotta subtract 4x on the right. So the x will cancel out, and on the left side will be just 2y. And then on the right side, 2 minus 4x cannot be combined because of number and a variable. So simply on the right side will be negative 4x plus 2. And then I want to get the y by itself, I'm going to divide everything by 2. So when I divide everything by 2, it will be simply be y equal negative 4x divided by 2 will be negative 2x. And then positive 2 divided by 2 will be plus 1. So here's our second slope-intercept. Now, as I'm looking at this second slope-intercept, I see that it is exactly the same as the first slope-intercept. Y equals negative 2x plus 1. Y equals negative 2x plus 1. So it's already graphed, and if I were to graph it again, so plus 1, that's our y-intercept, would be right here. And if I were to convert negative 2 into a fraction, so put it over 1, and since it's negative, it's going to go down 2, right 1, it is exactly going to be the same as that one. So if I were to graph it, it'd just simply be another line on top of it, like so. So it'd be the exact same line. So if you have a system, 2 equations, and when you converted to slope-intercept form, when they are exactly the same, which means two lines on top of each other, then the only thing it means is there's multiple solutions to this system. So I can use this x and this y, and it will work for these two equations. I can use this x and this y, and it will work for these two equations. I can use for this x and this y, works for these two equations. This x and this y, again, works for these two equations. So whatever you find corner points here, you're going to find more than one. So if you're going to find more than one, multiple solution, we call that infinitely many solutions. Or you could just say infinite solutions, but they mean the same. So infinitely many solution or infinite solutions. So again, to review, when you have two slope-intercept forms exactly the same, it means two lines on top of each other. That means that you have multiple points that you can use, and it will work for both equations. So you're going to have more than one solution, and it will work for both equations.